Okay, guys. Today let's see about Terraform. Okay, so Terraform is a infrastructure as code tool. Okay, so what is infrastructure as tool? So Terraform. Let's consider we have an AWS environment. Okay, so we have an AWS environment and it has multiple components. As we have seen in AWS, we have multiple components like EC2, uh, VPC, Route 53 and EKS. We have many resources, right? In AWS or any cloud. Let's take AWS here. It actually Terraform. It supports all the cloud providers. Okay, and then actually we have something called AWS Cloud Formation. Okay, we have something called AWS Cloud Formation. So it does the exact same thing which Terraform does. But what is the difference between AWS Cloud Formation and Terraform? So AWS Cloud Formation, it supports only AWS. Okay, it supports only AWS. Whereas in case if you want to migrate from AWS to Azure in future, then actually the code which you have written in this Cloud Formation, it will not support this Azure. Okay, so again you have to write the code from scratch. But what is the advantage of Terraform? In case if you write code for AWS, you can reuse the same thing in Azure. Okay, just you have to modify few configurations. Apart from that, this Terraform code which is written for AWS, it supports multi-cloud. Okay, you can create multi-clouds using the same configuration file. That is the main advantage of Terraform. Okay, and then we have seen something called infrastructure as code, right? IaC. Okay, so it is one of the hot tools in DevOps market. So what exactly does it do? So we have the infra. What does infra contain? Let's assume. Sorry. Let's assume a VPC. Let's assume a AWS VPC. Inside VPC, we will have multiple components. So we will have internet gateway, and then we will have route table, and then we will configure subnets. We will configure subnets like private and public. Okay, we configure subnets. We configure NAT gateway, NAT gateway. Okay, and then we configure route table and then internet gateway. So the structure will be like this, right? So okay, you get a request. Okay, you get a request to create a VPC with this configuration. Okay, so what you do, you go to AWS console. You do go to AWS console, create VPC, and inside these subnets, you will have EC2 instances. Okay, we will have this EC2 instances and all these things are okay. For example, if you get a request to create some resources, first you will go into the AWS console. You will first create VPC and then you will create different things inside it. Okay, you will create internet gateway, you will create route tables, and then you will create subnets, you will create NAT gateways, and then you will configure EC2, and then you will create security groups, everything. Okay, so for example, if you get one request to create a single VPC, then it is fine. Okay, let's assume you get a request to create 100 configurations. You have 100 configurations, and with 100 configurations you have to create some 50 servers. Okay, let's assume this as one server configuration. You have to create similarly the entire thing, you have to create 50 times. Okay, so to create this thing, if you takes like 30 minutes or so to create 50 servers, how long it will take? So it will take like many days, right? Like there may be issues, there may be like manual errors, and there may be some restrictions. Many things will be there. Okay, so how we can overcome this one? So how to overcome this one? So we can automate it. Okay, we can automate. Okay, so how we can automate? To automate this one, we have to use IaC. Okay, so what are the different tools available? We have Terraform. Okay, and then we have Pulumni, and then we have cloud respective tools. Okay, for in AWS we have AWS cloud formation. Okay, so we have all this, but the most popular one is Terraform. Okay, and recently IBM has purchased this Terraform, so it is an IBM product now. Okay, and Terraform, it has a beautiful documentation. Okay, like whatever resource you want, you can directly go to Terraform and then you can configure. Okay, so we have IaC, so we have to automate it. So how to automate? So you create a VPC configuration like vpc.tf. So Terraform files will be configured with tf. Okay, T means Terraform, tf means Terraform. Okay, so we have to configure vpc, we have to configure route 53, everything. You can create separate tf files, and then for example, for the vpc we have to provide a name, right? It is a variable, so we have to configure variables. So what we have to do, we will have this configuration. What we have to modify, we have to just modify the variables. For example, if we are creating VPC1, we can give VPC1. For second VPC, we will be passing the name as VPC2. So it will automatically create multiple VPCs automatically. So apart from VPC, like variables, nothing needs to be modified. So once you create a files, Terraform files, you can reuse it. Okay, you can reuse it multiple times. Okay, that is the advantage of using this infrastructure as code. So what we are exactly doing, we are converting the entire infrastructure. We have this infrastructure, right? We have this infrastructure, so we are converting this entire thing into code. Okay, we are making this entire thing into code. So instead of these static variables, we are passing dynamic variables. Just in the variables we will be instead of hard coding the values, we are just passing the variables. Okay, so by passing the variables, we will be able to create all these 50 servers within some time. Okay, this is the main advantage of IaC. Okay, Terraform. So what it does, so Terraform is a open source. Open source means it is free. Okay, and it is developed by HashiCorp. Okay, it is developed by HashiCorp, and then the language we write the Terraform files, right? .tf files. Those files are written in HCL. Okay, HashiCorp configuration language. Okay, and what is the main difference between Ansible and IaC, infrastructure as code? So Ansible, it's just for example, you have created an EC2 instance, and then you have installed an application or something. Okay, so in case if you have to modify the configurations, you can use Ansible. In case if you have to create the entire infra, then you can use IaC. Okay, so that is the main difference between them. Okay, so what are the key features? Declarative syntax. Okay, it describes desired state, and Terraform handles the rest. So what we do, we write the Terraform file, and it automatically it will create the environment in our cloud infra. Okay, and it supports multiple cloud. Okay, what we have, AWS, Azure, GCP, and then Kubernetes, everything, right? It will support everything. Okay, even we can execute Terraform on our local machine as well. Okay, and execution plan. So in case if you are going to for example, if you are going to create a resource, you can view that resource beforehand itself. Like you no need of waiting for it to be created. Okay, so you can see how it will be created beforehand itself. Okay, and then state management. So it tracks the infrastructure changes. For example, now we have like three VMs, three EC2 instances. In future, we create 10 VMs. Okay, or else now we use T2 medium, and then later on we use T2 large. Or else in case we configured the infrastructure as code TF file, and then we have given default size as T2 medium. Okay, but someone has logged into AWS console and changed the instance type from T2 medium to T2 large. Okay, but how does it know like what is the current state and how is the what is the current state and how it was previously? Using this state management. Okay, so that is easily managed in Terraform. And then modules. Okay, modules are nothing but it is a collection of files. It can be reused multiple times. Okay, so for example, if you write a configuration, the same thing can be used by different teams. Okay, like dev teams, prod team, operations team, everyone can use same module, just they can change the configurations based on their requirement. Okay, also in case if you have like different teams in your organization supporting different applications, they can use the same thing. Okay, what they have to do, they have to just modify the configurations based on their client requirement. Okay, so modules will be very helpful in maintaining this code. Terraform architecture. Okay, so the core components in this architecture are configuration files. Okay, it will be written in .tf file. Okay, tf means Terraform. and it is written in HCL. So ASCII configuration language. And Terraform core. What are the Terraform cores? So it will read the configurations. Okay, it will read the configuration because we have written the TF files. It will read those configurations and then it will create a plan. So this is what I will create. It will show us, and then we can manage that state. Okay, we will get the state files in Terraform, so we can manage that state. Okay, and providers. So what are providers? Providers are the different clients. Like we have different clouds, right? AWS, Azure. So Azure is a provider, AWS is a provider, GCP is a provider. Okay, and then state files, it tracks the real world scenario status. Okay, for example, in case if you have configured an environment, we can have the status of that one using this state file. Okay, modules for reusable code. Backend, so the state file, in case if the state file is deleted, the Terraform will not know what is the status of that infra. Okay, so what we have to do, we have to save that S3 in some safe location. Okay, we can use sorry, we have to store that state file in S3. So in case if you store in S3, you will in case if you enable the versioning, even if someone deletes, we will be the backup of that file will be available. Okay, or else you can save it in some safe locations, so that if some modifications are done in Terraform, you can restore them using this state file. Okay, so this is the conceptual diagram. What it does, you write the Terraform file. Okay, once the configuration files are ready, then the Terraform core is nothing but the Terraform application. Okay, so it reads all the configuration files and it analyzes what and all is required, and it will create those resources. It will create those resources in the providers. Means in case if you are using AWS, it will create in AWS, or else in case if you are using in Azure or some other cloud, it will create those resources in these providers. Okay, so it reads the configurations and it analyzes everything in Terraform, and then it creates the resources. Okay, so Terraform workflow. So you write the Terraform files and then you plan it. Plan means when you do Terraform plan, it will show like these are all the resources I am going to create. Okay, you created a Terraform file like for VPC route 53, all those things, and then when you do Terraform plan, it will show like I am going to create all these things like that. Okay, and then when you do Terraform apply, it will create those resources on the AWS environment. Okay, and then when you, in case if once everything is done, and in case if you no longer need that environment, you can do Terraform destroy. Okay, so that it will destroy the infrastructure. So these are all the key files which we will be creating. Okay, so main.tf. So main.tf is the main configuration. Okay, and then variables.tf. Variables.tf is the, we pass in the input variables. For example, you have to reuse the okay, we can see that one. So Terraform TF variables is Terraform related variable configurations. Okay, and then output.tf. For example, you are using an EC2 instance, and then you have to see what exactly is the public IP assigned to that EC2 instance. Okay, instead of logging in into that EC2 instance and check, you can check this outputs.tf. Okay, there in case if you have configured properly, that IP address of that particular EC2 instance will be reflected in this outputs.tf. Okay, and providers.tf. Providers.tf is in case if you have to like providers are like AWS, Azure, right? So in case if you have to connect to them, you have to provide their access key, everything, right? Credentials, everything. So you have to provide those things in providers.tf. Okay, so what are all the configurations we have? We have main.tf, variables to pass in variables. Like for example, you have created a TF file for creating an EC2 instance. Okay, and you can keep EC2 instance size as variable. Okay, for now you want T2 medium. Okay, then you can pass in T2 medium in variables.tf or terraform tf.vars. Okay, then what happens, it will automatically create an EC2 instance with the T2 medium, and someone else who needs with T2 large, that guy can pass in the variable as T2 large. Okay, so that it will create the infrastructure with T2 large, but he can use the same configuration. You have written the configuration, but other guy also he can use the configuration, right? So that is the main advantage of these variables. Okay, and the providers for different cloud providers and different tool providers, we can use this one. Okay, so if you see here example for main.tf. Okay, what you have given, provider. Okay, in case if you are not providing the provider details, then how it will know like where it has to create the resources? So you have to give the providers. Okay, so here I have given as AWS. Okay, and region, we have multiple regions, right? So in case if you have to create, if you are not giving this one, then it will not understand like in which region it has to create the resources. So you have to give the region. Okay, and then resources, resource. So what is the resource I'm going to create? I'm going to create an AWS instance, okay? And then you can give the name. For example, if you are creating some Apache, like you can give the name as Apache, okay? And then AMI is image ID, okay? We will have multiple image IDs, right? In like for example, we have RHEL 8, RHEL 9, RHEL 7, many things are there, right? So in case if you have to use RHEL 9, then you have to give the ID of that RHEL, okay? Otherwise it will not know like which image to create. And instance type, for example, if you need that instance to be of T2 micro, then you can give T2 micro. In case if you need T2 large, you can give T2 large, okay? So these things will be defined in main.tf. And variables.tf, so you have to pass in, like in case if you see, the AWS and different clouds will be passed under provider, okay? And these resources will be passed under AWS instance. Like we have AWS instance, in case if you have to create S3 bucket, those things should be passed under resources, okay? And then variables, so variables will be passed for different things. For example, if you need instance type, for example, here we have given as instance, okay? So okay, the example is not clear. Now let's see, okay? So it will be tough to remember all these things, right? So we have the beautiful documentations from Terraform, okay? Terraform, for example, so Terraform, this is the official page. If you see Terraform by Ashikop, okay? So docs. So we have different documentations for different things, okay? Um, okay, that's fine. So what you can do, you can, for example, you have to create an EC2 instance, okay? You can type Terraform EC2, okay? So you will get immediately you will get a resources related to those things, okay? Just click on this one. So if you see here, you can just scroll down. Once the classes are completed, then you will be familiar with these things. So we will get things like this, okay? So you can go to the bottom. So you can use different configurations. If you see, they have given different configurations, like they have given AMI instance type, and then they have given tags as well. And then in case if there is a owner, you can give the owners. So in case if you have to create a VPC, you can give resource AWS VPC and then VPC name, CIDR blocks, and then tags. Okay, inside this you can give availability zone and then subnets. You can give subnet name, IPs, private IP, and then instance type, everything. So if you scroll down, so here is the usage. Okay, so you can just copy this one. Okay, if you copy this one, uh, the same thing. We have resource, right? So resource, okay, AWS instance. So AWS instance, here they have given the name as this. Here you can give name whatever you want, and then AMI, you can get this AMI details from your AWS console, okay? So when we do the demo, we will get to know these things, okay? And instance type, they have used M5 large, so here we have used T2 micro. So based on your requirement, you can modify. So you can always refer to this documentation for any help, okay? See, the documentations are very good. You can always use this one, okay? So similarly, if you see variables.tf, so variables should always start with variable, okay? And then we are passing the variable for instance type, okay? And then description you can give whatever you want, just for your understanding, okay? And type, we are giving it as string means like we have to pass it as alphabets, okay? And then default, okay? Default, in case if you are not giving the instance type anything, if you're not defining anything, automatically it will take T2 micro, okay? In case if you're not defining anything, it will take T2 micro. Otherwise, okay, here you are given variable as instance type, right? So instead of for instance type, you have defined in variables.tf. But you have not defined any value, right? You have not defined any value. So how you define this value? You define this value in terraform.tf vars. Okay, inside this terraform.tf vars, you have given instance type equal to T3 large. Okay, now what happens? This T3 large, it will go and it will apply here. Okay, so now let's copy this one. So what happens? So we have defined variables.tf. Okay, this is variables dot tf, and this is terraform dot tf vars. Okay, now what happens? So for example, you have created some main.tf. Okay, you have created a main.tf, and in that you have created providers, and then all the details you have provided. Okay, and then in the variables you have to pass instant type. Okay, here you have not, you have just given this one, and then for example you have not defined anything. Okay, you have not defined anything here. Okay, then what it does, it creates the ec2 instance with the t2 micro. Okay, but in case if you in the terraform.tf files, if you are given instant type, so instance type is the variable. Here this is the variable. Okay, so in case if you are given instant type equal to t3 large, then this value will be replaced to this one. Okay, it will create ec2 instance, ec2 instance with t3 large. Okay, this is how we use variables. Okay, and then core comments. Okay, so when first thing you have to do is terraform init. So what this terraform init does, you have configured the aws in the provider section, right? But this, in case if you want to, so if terraform want to support this aws, it should have the dependencies installed, right? So how do this terraform gets all the dependencies to connect to this aws? So you have to use terraform init. When you do terraform init, it will automatically download all the dependencies required to that aws or any other cloud provider. Okay, and then terraform validate. So before you do anything, you have to check terraform validate. So what it does, it checks the syntax. You written the terraform file .tf file. How do you know whether it is correct or not? Okay, so in case if you want to check whether the terraform file is correct or not, you can use terraform validate. Okay, and terraform format. Terraform format is that you have written the terraform file, and then the validation is also successful. But in case if you are not arranging it properly, it may look gibberish, right? So in case if it has to look nice, then you can format. So it will format the entire terraform file, and it will look nice. Okay, and terraform plan. Okay, before you apply, when you do terraform plan, it will show like we are going to create this vpc, we are going to create this many routers, and then we are going to do these things, and all these components will be created. So all those details, like what are all going to be created, it will be shown during terraform plan. Okay, and then if we want this plan to be applied in aws infra, we can do terraform apply. Okay, and then in case if you have to destroy the created configurations, then you can use terraform destroy. Okay, and variables. So the same thing we have discussed here, right? So variables are passing the variables. Okay, and outputs. So for example, you have an aws instance, and you have to know its public ip or private ip, whatever it is. So you can get those things using output. Okay, you have to pass in as output. For variable, you have to pass variable. Okay, and for provider, you will give provider. And resources, for example, if you're creating s3 ec2 or something, those are easy, like aws resources, right? So you have to pass it as resource. Okay, so resource, provider, and in case of variables, we have to pass variables, and then for outputs you have to pass output. Okay, and terraform modules. Okay, so modules are like it is a structured way. Okay, so for example, we have a module. So you have to create a vpc. In case if you have to create a vpc, we will have main.tf. Okay, in main.tf we will configure all the main configurations. And in variables, for example, like name, like a vpc name, all those things are like it will change from one team to another, right? So you can pass those things in variables. Okay, and outputs, for example, once this is executed, you want the vpc name or else some subnet names to be visible, then you can configure the output.df. Okay, so if you see, we have the module, you can define all the sources, and then so how you can use these modules, you have to define module. Okay, first if you want to use module, there are many predefined modules also. Okay, those are all available in terraform documentation. So you can use module in the first word, and then you can use vpc. We are going to use vpc, right? So vpc, and source, where exactly this vpc configuration is there. So it is under here they have given dot slash modules vpc. In case if you are keeping it some other location, you can just give the full path. Okay, and you can define cider block. In case if you have not defined them in main.tf, you can configure this cider block as well. Okay, so that it will create the it will use the modules, existing modules. And then state management. Okay, so when you create a terraform infrastructure, it will create a terraform state file. Okay, so the state file contains all the configurations related to the infrastructure. Okay, so when you do Terraform state list, it will show all the state files. So in case if the Terraform state file is deleted, then Terraform will not know what it created and it will not know how to manage those things. Okay, so always we have to safeguard this state file. You can save it in any of the S3 buckets or some safe locations so that it will be safe. Okay, so how we can use S3 to save that one? You have to use backend. Okay, we are using Terraform at first line, and then we are using backend. So backend where we are saving it in S3. Okay, and then we have to give the bucket name. Like you have to create a bucket and we have to give the bucket name, and then key and a region, like in which region that bucket is there, and then key like that state file name. For example, if you are using state.tf state, you can give that one. Otherwise, in case if you have different name, you have to give that one. And provisioners. Okay, so for example, you have a local system and you have to execute something on your local machine, then you can use this local exec. Okay, local exec. And then in case if you have some remote machines and if you have to install any of the configurations there, we can use remote exec. Okay, so all these things we can see in future classes in the demo sections. Okay, so workspaces. Okay, so what are workspaces? For example, you have different environments. Okay, for example, you have dev, staging, prod, pre-prod, everything. Okay, you have to check how you have to work on different environments, right? So how you can work? You can create workspaces. Otherwise, in case if you are not using workspaces and then you are using same configuration for all the environments, then the state file. Okay, so you have different environments. Okay, we have dev, staging, and prod. Okay, so we have one file. Okay, like we have main.tf, variables .tf, output.tf, and then terraform vars.tf. Okay, so we have all this configuration file. Okay, for example, here in variables you pass it as dev. Okay, and then it will create a state file. Okay, once you create environment, it will create state file. Okay, but for next time you are changing it to staging. Okay, when you change it to staging, all the, for example, in dev you may need like t2 medium. Okay, that is fine to work with the dev environment, but for staging you may need t2 large, and for prod you may need t2 extra large. Okay, so the sizes vary and then state files get overwritten, and then many issues will happen, right? So instead of this, once the state file is updated or deleted or something happens, then what happens? Then actually we will have issues. Okay, with the environment, Terraform, it will not know what exactly the configurations are, and it will get confused. Okay, so what we can do, we can maintain this environment separately. We can have separate environment for dev, separate environment for staging, and separate for prod. So how we configure this one? We configure those things using workspaces. Okay, so we create workspaces. So we create workspaces for dev, staging, and prod. So what happens? It will create separate state file. It will create separate state file for dev, separate state file for staging, and a separate state file for prod. So you will have separate configurations and it will have idea like what resources it is managing. Okay, so that is the use case of workspaces. So how to create a workspaces? Terraform workspace, new dev, and to list the workspaces, Terraform workspace list, so that it will list all the workspaces available. Okay, in case if you have to work in dev, staging, or prod, any of the particular workspace, you can select Terraform workspace, select dev. For example, if you have to work with dev, in case if you have to work with prod, Terraform workspace, select prod. Okay, so what are the best practices for Terraform? Always use git for Terraform files. In case if it is deleted, you can just roll back and you can get those Terraform files. And always use some storage like S3 or something for storing that state files, so that the configuration files are safe. And you have to always use modules. Okay, so if you are using modules, you will be able to reuse the code. Okay, so and troubleshooting. So in case if you have to troubleshoot any of the configurations, you can define export tf-log equal to debug. Okay, and then when you do Terraform apply, you can enable the debugging. Okay, so this is what Terraform is. So going forward, let's see demonstrations of each and every component we discussed. Okay, so that we will become proficient with this. Okay, yeah, that's it, guys. So let's see tomorrow.